This is a question related to find the momental ellipsoid. Okay, so this question is very important, and it is very important for the exam point of view also. So in this question, we are taking a uniform solid rectangular block is of mass m and dimension 2a, length is 2a, breadth is 2b, and height is 2c. Then they are asking you to find the equation of the momental ellipsoid for a corner O. Means we have to find the equation of momental ellipsoid at the corner O of the block. Refer to the edges to O as the coordinate axis. Means we have to take the axis through the corners. That is, OX is the x-axis, OY is the means we will take the axis as the OX, OY, and OZ. So this is your y-axis. Okay, so this is y-axis, OY. So this will be your y-axis. So refer to the axis as O as the coordinate axis, and hence determine that we have to find the moment of inertia about OO dash, where O dash is the point diagonally opposite to O. Means O is here, so opposite to O we taken as O dash, where O dash is opposite to O, diagonally opposite to O. Now we are taking, let us take x, y, and z axis along the edges of length, means 2a, 2b, and 2c. Means we are taking the x-axis along the length 2a, y-axis along the length 2b, and z-axis along the length 2c respectively. And the mass of this rectangular block we are taking as m. So we can find the mass. This is same as what we have done last time about the parallelepiped. So we have to do in the similar manner for the parallelepiped. I have given you as your homework to find the moment of inertia of a parallelepiped about the corner. So we have to follow that only. So here mass per unit volume is nothing but mass divided by volume. Volume of is length into breadth into height. So length is 2a, breadth is 2b, and height is 2c. So we get m into 2a into 2b into 2c. That is nothing but m by 8abc. So we get the mass per unit length is m divided by 8abc. So here we have the mass of the element. You take one element inside this block. So if we take an element inside this block, and if the length of that element is delta x, breadth is delta y, and height is delta z, then the mass, if I take one point inside that one, then the mass of that element, the mass of the whole thing of that element will be nothing but m divided by 8abc, the volume of that element, that is nothing but delta x into delta y into delta z. Now we know distance of the point P from the OX is nothing but y squared plus z squared to the power half. Distance of the P from the OY axis, OY, is z squared plus x squared to the power half. Distance of the point P from OZ is x squared plus y squared to the power half. Now we are trying to find A, that is moment of inertia about the x-axis. So we have the formula summation delta m y squared plus z squared. So now we are taking at the corner, so the limits will be 0 to 2c, 0 to 2b, 0 to 2a, and delta m is the mass per unit length, so that mass of the element. So mass of the element is m by 8abc. Delta x I'm replacing with dx, delta y I'm replacing as dy, and delta z I'm replacing as dz. And here we have y squared plus z squared, so I'm writing here y squared plus z squared. So you try to integrate this. So if you integrate this, you will get the answer to be this 4 by 3 m b squared plus c squared. Same way we try to find the moment of inertia about the y-axis. So the formula is summation delta m z squared plus x squared. So it is from 0 to 2c, 0 to 2b, and 0 to 2a. So mass delta m, we know that like previous, we have m by 8abc, dx, dy, dz, and z squared plus x squared we are writing here. So we try to integrate this, and we get it is 4 by 3 m c squared plus a squared. C is the moment of inertia about the z-axis, so we get here summation delta m x squared plus y squared. So integration is, since we are taking from the corner, at the corner the integration limits of the integration will be from 0 to 2c, 0 to 2b, 0 to 2a, m by 8abc, dx, dy, dz, x squared plus y squared. So we integrate this, so we get the integration to be 4 by 3 m a squared plus b squared. So now we are trying to find d. D is nothing but product of inertia, so summation delta m yz. So limit will be 0 to 2c, 0 to 2b, 0 to 2a. This is the mass delta m 8abc, dx, dy, dz, and yz. So we are putting yz. After that, you try to integrate this, so we get mbc. In the same way, you try to find E also in the similar manner. So we get this integration to be MCA, and F will get here the integration to be MAB. So you proceed in the similar manner as we have done already before in the previous videos and in the previous question. So we proceed in the same way, and you try to find all this A, B, C, D, E, and F. Now we try to find what they are asking you to find, the equation of the momental ellipsoid. Okay, so the equation of the momental ellipsoid. So we have that formula which we have done in which we have done just now. The equation of the momental ellipsoid is nothing but this. Okay, so ax square plus by square plus cz square minus 2 dyz minus 2ezx minus 2fxy equal to m epsilon 4. We are going to put this value of a, b, c, d, e, and f in this equation. So if we put this value of this in this equation, we get 4 by 3 m b square plus c square x square plus 4 by 3 m c square plus a square plus 4y square plus 4 by 3 m a square plus b square z square minus 2 mbcyz minus 2 mca zx minus 2 mabxy, which is equal to m epsilon 4. So the other part I'll explain in the next video.